For years, the same wall stopped almost everyone who tried to leave Windows behind. People installed Linux, got comfortable with it, started genuinely liking it, and then one single program brought the whole experiment to a halt. Photoshop wouldn't run. Microsoft Office wouldn't run properly. That one obscure internal tool they'd relied on at work for a decade simply refused to function at all. The compatibility layer most people reached for to solve this problem is a project called Wine, which has been quietly attempting to translate Windows software for Linux since 1993. More than 3 decades of sustained volunteer engineering effort, and even after all that time, it still cannot reliably run the full Adobe Creative Suite, and it still regularly chokes on modern versions of Microsoft Office. The wall held, for over 30 years, against one of the most ambitious open source software projects ever attempted. Now, a free open source tool has emerged that actually gets past it. It runs Photoshop, it runs Microsoft Word and Office 365, it runs FL Studio, it runs Affinity Photo. Users have reported running that stubborn old program from their previous job that nothing else could handle. Some have even kept demanding professional engineering software like SolidWorks running for extended stretches without major issues. And the way the developers pulled this off involves a trick simple enough that it almost sounds like a joke. The tool is called WinApps, and here's exactly how the trick works. WinApps doesn't attempt to translate Windows programs into something Linux can natively understand, the way Wine does. It doesn't imitate Windows, and it doesn't pretend to be Windows. Instead, it quietly downloads an actual copy of Windows 11 directly from Microsoft's own servers, installs that real copy of Windows inside a self-contained virtual machine running on your Linux computer, and then projects each individual Windows program onto your Linux desktop as its own separate, ordinary-looking window. You click an icon, and Photoshop opens. You move it around, resize it, and work inside it right alongside your native Linux applications. Underneath all of that, a genuine, complete installation of Windows is quietly running in the background, doing exactly what Windows has always done. The compatibility ends up being remarkably close to total for one very blunt reason: nothing is actually being translated or approximated. The program genuinely believes it's running on Windows because, technically, it is. And here's the part of this story that turns it into a real problem for a company worth well over $1 trillion. The copy of Windows, running inside that virtual container, is the standard free trial installer Microsoft makes publicly available for download. It is never formally activated with a paid license. Nobody in this entire arrangement purchases a Windows license at any point. Microsoft publishes that installation file openly on its own servers, and Microsoft's own installer permits it to run in an unactivated trial state without hard-blocking core functionality. WinApps essentially just connects those two publicly available facts together for you, automating a process that was technically already possible but practically inaccessible to most people. The company that spent roughly 3 decades ensuring people needed Windows now provides, freely and directly, the one component that lets someone stop paying for it. To understand why this genuinely matters, it helps to understand exactly why the older approach kept coming up short. Wine works by intercepting the specific system requests a Windows program makes and rewriting those requests, lev, into equivalent instructions Linux can actually process and answer. It stands as one of the most ambitious and long-running volunteer software efforts ever attempted, sustained by a large community of contributors across more than 3 decades. For gaming specifically, Wine has genuinely delivered a real triumph. Valve built its entire Proton compatibility layer directly on top of Wine's underlying translation engine, and that layer is the core technology that made the Steam Deck's entire library of playable Windows games possible in the first place. In January 2026, the project shipped Wine 11, a major release carrying years of accumulated technical improvements. But translation, no matter how refined, inherently has a ceiling. A modern professional application makes literally thousands of low-level system calls that are welded deep into Windows' own architecture, spanning licensing systems, copy protection schemes, and rendering pipelines. Get even a single one of those translated calls wrong, the program either crashes outright or refuses to launch at all. For years, the honest answer to "will my program run on Linux" was consistently the same. Maybe check a compatibility database first, hunt down missing supporting libraries, and expect to spend real time tweaking obscure settings before anything reliably worked. WinApps looked at that entire 30-year struggle and essentially declined to keep playing the same game. Instead of translating the demands a Windows program makes, it simply supplies a genuine copy of Windows underneath and lets that real operating system answer those demands directly, the way it always has. It's worth being honest that pieces of this underlying idea existed well before WinApps, and the people who built earlier versions have real scars to show for the effort. VirtualBox offered a seamless window mode for virtual machines as far back as 2009. More recently, earlier community projects wired together the same basic core ingredients, a virtualized copy of Windows paired with a remote display protocol, but required users to manually assemble most of that setup themselves through a terminal, piece by piece. Doing that manual assembly was, by most accounts, genuinely miserable. Documented user experiences describe months spent fighting persistent graphical glitches, leftover visual artifacts from windows that had already been closed, and a mouse cursor that lost input focus in unpredictable ways. Frustrations severe enough that some users eventually abandoned the entire setup as not worth the ongoing maintenance burden. That was, for a long time, genuinely the state of the art for this approach. WinApps took that intimidating, hand-assembled pile of separate components and wrapped the whole thing in an automated setup process. It fetches the Windows installer on your behalf. It handles the installation itself. It builds out your list of available applications automatically. Install a program inside the container and its icon simply appears in your regular Linux application launcher, ready to open directly on your Linux desktop like any native app. The underlying idea itself isn't new. A version of it that an ordinary non-technical person can actually set up and use reliably genuinely is. And the practical results for a large share of everyday software are genuinely difficult to argue with. Users consistently report Microsoft Office 365 installing cleanly and signing in without complications, with Word, Excel, and Outlook behaving essentially like native applications once configured. FL Studio runs largely as expected for music production work. Affinity Photo functions reliably for most standard editing tasks. One tester spent an extended period running SolidWorks, among the more demanding professional engineering applications in wide use, and reported that outside of especially graphics-intensive operations, nothing serious broke during that stretch. A related, similarly focused open-source project called LinOffice uses this same underlying technique specifically to deliver Microsoft Office on Linux systems. It's important to be honest here, though, about where real limitations still exist, because the picture isn't uniformly glowing across every category of software. Independent hands-on testing of WinApps has found that genuinely GPU-intensive creative applications, Adobe Photoshop being the clearest example, run into real trouble specifically because the virtual machine's display connection relies on a relatively basic graphics driver passed through a remote display protocol, one that lacks access to the kind of dedicated GPU acceleration that modern versions of Photoshop increasingly depend on for core functionality. Some testers have encountered outright unsupported GPU error messages when first launching Photoshop under this setup, even though a number of the program's more basic, less GPU-reliant features do still function afterward. Document work, spreadsheet work, general office productivity, and music production tend to run smoothly. Heavy GPU-dependent creative work is a genuinely mixed picture right now, not a guaranteed win. And that distinction matters for anyone considering this specifically to replace a graphics-heavy professional workflow. The 30-year-old wall didn't get climbed here through some technical breakthrough. It got bypassed cleanly for a wide range of everyday software and only partially for the most GPU-hungry professional creative tools. Now, for what glossier summaries of this project tend to leave out, because you genuinely deserve the complete picture before installing anything like this on a machine you rely on. First, WinApps remains in active beta development and has not yet reached a formal version 1.0 release. The developers themselves state plainly that users should expect occasional hiccups and bugs, that a reasonable comfort level with basic troubleshooting is genuinely necessary, and that the current release is explicitly not considered the finished product. That's refreshingly direct honesty from an open source project, and it's worth taking at face value rather than assuming everything will work perfectly out of the box. Second, there's currently no dedicated graphics card acceleration built into the setup. Document editing, general office work, and music production generally function well, but GPU-intensive video editors like Premiere Pro tend to run noticeably laggy, and using WinApps for any kind of serious gaming is essentially pointless given the display limitations involved. Games relying on kernel-level anti-cheat systems won't run through this setup either. For the exact same underlying reasons, those specific anti-cheat systems already refuse to function in most other non-native Windows environments. Third, the display layer itself, built on the open-source FreeRDP remote display protocol, isn't entirely flawless. Users report occasional rough edges, particularly with applications that spawn multiple secondary windows, and on setups involving more than one connected monitor. It represents a dramatic improvement over the earlier hand-built versions of this same underlying idea, but it's fundamentally a remote display protocol handling a job it wasn't originally engineered for, and that limitation does occasionally show through in practice. Fourth, the initial setup process includes at least one genuinely challenging step. WinApps depends specifically on a container platform, either Docker or Podman, along with the FreeRDP remote display client, And getting those underlying dependencies properly installed means following setup instructions carefully, frequently involving direct use of a terminal. The tool itself does check each requirement along the way and links out to setup guides for every dependency it needs. But this is realistically the exact point where a rushed or impatient user is most likely to give up on the whole project. Following the documented steps precisely, without improvising shortcuts, tends to make the difference between a smooth setup and a frustrating one. Fifth, plan your hardware allocation honestly and realistically before starting. You're effectively keeping a full second operating system running quietly in the background alongside your primary Linux install. Reasonable starting resource allocations tend to be around 2 processor cores, 4 gigabytes of memory, and at least 32 gigabytes of dedicated disk space, with more of each recommended specifically for heavier creative workloads. As a general rule, avoid allocating more than roughly half of your machine's total available resources to the container. It's also worth knowing that if you configure the container to start automatically every time your computer boots, that allocated memory stays reserved and unavailable, even while you're not actively using any Windows programs at all. Some users have specifically traced unexpectedly high idle memory usage on their systems directly back to this exact setting. The fix is straightforward. Disable automatic startup on boot and only launch the container manually when you actually need to open a Windows program. So what does all of this practically mean for someone currently sitting on an older Windows machine that Microsoft has spent the past year quietly nudging toward replacement? It means the single most common excuse people have relied on for staying on Windows is genuinely losing its footing. For a huge number of longtime Windows users, the real reason they'd stayed was never any particular fondness for the operating system itself. It was almost always one specific, seemingly irreplaceable program standing in the way of switching. Tools like WinApps exist precisely to address that exact scenario. You move the bulk of your daily computing life over to Linux, where the persistent telemetry concerns, the forced update cycles, and the advertising increasingly baked directly into the Windows Start menu simply aren't part of the experience. And you keep one small contained Windows environment available on standby specifically for that one stubborn holdout application. You open the container when you genuinely need it, and you close it again once you're finished. Windows shifts from functioning as your primary operating environment to functioning more like a specialized tool sitting quietly in a drawer, available whenever it's actually required. It also means this particular transition genuinely has a low-risk exit path, even for people who prefer to stay cautious rather than commit immediately. Nobody has to fully commit up front. You can install Linux, install WinApps alongside it, and if the entire experiment simply doesn't work out for your specific setup, you've realistically lost little more than an afternoon of testing time. Anecdotal reports from people who tried this approach and ultimately stuck with it consistently suggest they didn't switch because anyone lectured them about the abstract merits of open source software or digital freedom. They stuck with it because the one specific thing that had genuinely been holding them back finally stopped holding them back. Step back for a moment and look plainly at what has actually happened here. Microsoft spent roughly 3 decades building a genuinely effective moat constructed almost entirely out of software exclusivity. The simple, practical reality that a huge amount of essential professional and creative software would only reliably run on Windows itself. That moat is a meaningful part of why businesses kept paying for Windows licenses, why families kept buying new Windows machines, why so many people, who might otherwise have preferred an alternative operating system, felt they genuinely had no realistic choice. A relatively small, still actively developing open source project, one that hasn't even reached a formal 1.0 release yet, found a practical way to hand ordinary Linux users meaningful access to the contents of that same moat, using nothing more than a free installation file Microsoft itself already makes publicly available at no cost whatsoever. It isn't a finished, flawless solution. The graphics acceleration limitations are real and well documented, and the beta label attached to this project is genuinely earned rather than just cautious marketing language. But the underlying direction here is fairly unmistakable, and the developers behind it continue shipping meaningful improvements on an ongoing basis. The real question was never really whether Linux, as a desktop operating system, was good enough for everyday use. For a large share of typical computing tasks, it already has been for years. The actual question was always whether that one specific stubborn holdout program would keep holding people in place indefinitely. For a growing and genuinely wide range of that software, in most practical cases now, the honest answer is that it runs.